All right, so in this video, we're going to look at the orange section of your rainbow review. Starting with number 1, so just to review with horizontal and vertical asymptotes. Remember the vertical asymptotes, that's what we get from our denominator. Okay, so we get that from the factored form of our denominator. So if I set each of those factors equal to 0, we would get x would equal 0 if we set 2x equal to 0. And x plus 1, if I set that equal to 0, I would get x equals negative 1. We do want to write these as separate equations. You don't want to say x equals 0, comma, negative 1. Each of these would be their own separate equation. So x equals 0, x equals negative 1 would be your two equations for your vertical asymptotes. And again, you get that from setting the factors of your denominator up equal to 0 and solving those. All right, now your horizontal asymptote is different. The horizontal asymptote looks at the degree. The degree is your exponent. But we have to, a degree we get when it's in standard form. The numerator is in standard form, but the denominator is not. So this would be the same. If we simplify this denominator, we would have 2x squared plus 2x. So this tells me the degree in the numerator is 1, the degree in the denominator is 2. Remember, for the horizontal asymptote, if the degree in the denominator is bigger than the one in the numerator, that always means that your horizontal asymptote is at y equals 0. So if the degree in the numerator is smaller, okay, so if you say, just two ways to look at it. If your degree is smaller in the numerator than it is in the denominator, your horizontal asymptote is at y equals 0. Or if you say it that, if you think of it as, if the degree in the denominator is bigger than the one in the numerator, y equals 0, it doesn't matter, whichever way works for you. But in this case, our horizontal asymptote would be y equals 0. Let's look at the next one. All right, so for number 2, remember, the vertical asymptote we get from our denominator, but we need to make sure that it's in factored form. So the denominator in factored form, this is a difference of squares. So this would factor to be x plus 5 times x minus 5. So your asymptotes, we get those by setting each factor equal to 0 and solving them. So if I set the first one up equal to 0 and solve it, I would get x equals negative 5. And the second factor, if I set that equal to 0 and solve it, I would get x equals positive 5. Again, if you do this, you do not want to separate these. You do want to separate these with separate, or you want to write these as separate equations. You don't want to say x equals negative 5, comma 5, because each asymptote is its own equation. All right, the horizontal asymptote we get by comparing the degrees in the numerator and the denominator. So they have to be in standard form. So we look at the standard form of both of those. And so I see that when it's in standard form, the degree in the numerator is 2, and the degree in the denominator is also 2. So if that's the case, if the degrees are the same, we look at the leading coefficients. So the leading coefficients are both 1. So 1 divided by 1 equals 1. So that means my horizontal asymptote would be y equals 1. Now let's say if we had like a 3 in front of here, then it would be 1 over 3. So our horizontal asymptote would be at y equals 1 over 3. So I just want to make sure that that's clear. All right, let's look at number 3. So with number 3, again, the vertical asymptote, we get that from our denominator, but the denominator, in order to get that vertical asymptote, needs to be in factored form. So for this one, I recognize that I can factor out a 5x. When I do that, I get x minus 5x times x minus 3. So I'm going to set each of those factors in the denominator equal to 0. We don't care about the numerator. All we care about is the denominator. So if I set 5x equal to 0 and solve it, I would get x equals 0. If I set x minus 3 equals to 0, I would get x equals 3. And again, you have to write these as their own separate equations because these are asymptotes. An asymptote is an equation, so they each have to have their own separate equation. A horizontal asymptote, we get that by comparing the degrees of the numerator and the denominator. So again, for this one, I see that the degree in the numerator is 1. I see the degree in the denominator is 2. So since the degree in the denominator is bigger, we would say that the horizontal asymptote, whoops, let me use a pen here. We would say that the horizontal asymptote is at y equals 0. So anytime the degree in the denominator is bigger than in the numerator, we always have a horizontal asymptote of 0. Now let's say, there wasn't an example like this, but let's say the numerator had a degree of 2 and the denominator a degree of 1. Well, in that situation, if the degree is bigger on top, then there is no horizontal asymptote. So that was The only other one that was not covered in this Rainbow Review. All right, let's look at this one. So here we're going to graph the function of x plus 5 over x plus 2. Okay, the first step is to figure out where are our asymptotes at. Okay, our asymptotes are going to be, well, let's start with the horizontal asymptote. Since the degree here is 1, the same of both of those. That means that our horizontal asymptote, we're going to look at the leading coefficient of both of those. So the horizontal asymptote would be at y equals 1 over 1, which is the same as 1. So I'm going to draw a horizontal line going through y equals 1. So now let's figure out where our vertical asymptote is going to be. Our vertical asymptote, we're going to set our denominator equal to 0. So if I set x plus 2 equal to 0, I would get x equals negative 2. So I'm going to have a vertical asymptote at x equals negative 2. Now to figure out where our line is going to be, to sketch a graph of our line, what we're going to do is we are going to start by just creating an xy table. Now I'm going to pick numbers that make sense, and so I'm going to pick numbers close to, we're going to pick numbers for our x values close to our asymptotes. So like maybe negative 1 and 0. Okay, just for a couple. So if I put negative 1 in my equation, I would have negative 1 plus 5, which would be 4. And negative 1 plus 2 in my denominator would be 1. So when we put negative 1 in there, we get 4 as our answer. When we put 0 in there, well, 0 plus 5 would be 5, and 0 plus 2 would be 2. And 5 divided by 2 would be 2.5. So when x is negative 1, y would be 4. When x is 0, y is 2.5. And then we can just sketch our line. Would look something like that. Okay, but we have another branch. We have another branch that has moved from where quadrant 3 was to this area over here. So we need to figure out what is a branch over there going to look like. So I'm going to pick, again, values that are close to that the vertical asymptote. So I'm going to use negative 3 and negative 4. Whoops. There we go. Negative 3 and negative 4. When I put negative 3 in there for x, I get negative 3 plus 5 would be 2, and negative 3 plus 2 would be negative 1. Well, 2 divided by negative 1 is negative 2. And then I'm going to put negative 4 in for x. So I'd have negative 4 plus 5 would be 1, and negative 4 plus 2 would be negative 2. So we get negative 1/2. Negative 0.5. So I'm going to graph those. When x is negative 3, y is negative 2 would be right here. When x is negative 4, y is negative 1/2, which would be right about there. So I'm just going to draw a line that goes through those points. So that would be a sketch. That's how we could sketch the graph for number 4. All right, let's look at the back side now. So number 5, on the first one on the back page, says simplify the expression and write an expression that is equivalent, give the domain for your expression. All right, so the first step is we have to simplify the numerator and denominator. We're going to factor that down. So x squared minus 4 is the same as, let me get a pen instead of a highlighter here. This will be, the numerator factors to be x plus 2 times x minus 2. That's a difference of 2 squares. The denominator, since our leading coefficient is 1. This is one of those we can factor down easily. And to do that, we would just look to see what two numbers multiply together to be 8 that add together to be 6. And that would be 2 and 4. So x plus 2 times x plus 4. Because 2 times 4 is 8 and 2 plus 4 is 6. So for your domain, so before we simplify this, I always like to identify what the restrictions of the domain can't be. So the domain, x can't equal negative 2 and x can't equal negative 4. Because if we'd set each of those factors in the denominator equal to 0 to find it, because we can't divide by 0. So we want to figure out what values for x would give us 0 in our denominator, and that would be negative 2 and negative 4. So x can't equal either of those. All right, but now to simplify this, I recognize that x plus 2's would cancel out. So it would simplify to be x minus 2 divided by x plus 4, with the restriction in our domain of x can't equal negative 2 and x can't equal negative 4. All right, let's look at number 6. So for number 6, I'm going to start by factoring the numerator and the denominator, because in order to figure out how to simplify this, we need to get both the numerator and denominator in factored form. So in the numerator, I see that we can factor out a 3x. Now you got to be careful. If we start out with two terms originally, we're going to have two terms in parentheses. So sometimes I'll see people when they factor out a 3x, in a situation like this, say, oh, well, that means this disappears. No, 3x divided by 3x would be 1. So let's start with the 3x squared. Well, since 3 divided by 3 would be 1, when we factor out an x, we're left with just 1x. Or you could just say x. And then we have negative 3, so we'll have a minus here. So then 3 divided by 3 again would be 1, and x, factor that out, would still just be 1. So in other words, you should always be able to distribute what we factored out and get what you had originally. And that would happen here. All right, the denominator. I'm going to factor this down. So I notice that my a value again is 1. My leading coefficient is 1. So this is one of these we can factor down simply. So we want to find two numbers that multiply together to be a positive 3 that add together to be a negative 4. Well, that means that they both have to be negative. So it would be a negative 1 and negative 3. So negative 1 times negative 3 would be a positive 3. And negative 1 plus negative 3 would be negative 4. All right, before we cancel things out, I like to identify what restrictions we have in our domain. And that would be, well, we can't divide by 0. So if I set each of those factors in our denominator equal to 0, I would get x can't equal positive 1 or a positive 3. Because if you set those equal to 0 and solve them, that's what you get. So that means that if you were to put 1 in here, we get 0 in the denominator, or if we put 3 in there, we get 0 in the denominator. We can't have that. So x can't equal 1 or 3. So now let's look at how we could simplify this. So I see the x minus 1's cancel out, leaving me with just the 3x in the numerator and the x minus 3 in the denominator. So that would be your simplified form for that fraction. All right, looking at these last three, what we're doing here is we're multiplying these or dividing these fractions. So it's always important to recognize what we're doing with each, because that affects things. So this first one we're multiplying. So before we multiply those, let's simplify it. So I'm going to factor the numerator, factor any of these numerators and denominators. So the first one, the only thing that really factors is the x squared minus 49. That factor, since that's a difference of squares, that factors to be x plus 7 times x minus 7. The denominator, just do this. The denominator would just be 10x squared. Can't do anything with that. The other one I can't do anything with either. So we'd have x minus 7. Okay, before I cancel things out, let's look to see, oops, x minus 7, not x minus 1. Let's see what restrictions we have in our denominator. Okay, so I'm going to set each factor equal to 0 and solve it. So if I set 10x squared equal to 0 and solved it, some people had a question about this one. If I divide by 10, I get x squared equals 0. Well, if I take the square root of 0, we just get 0. So that means x can't equal 0 is one of our restrictions. Another restriction is that if I set x minus 7 equal to 0 and solve that one, we get that x can't equal 7. So x can't equal 0 and x can't equal 7. All right, so now let's look to see what we can cancel out here. We have an x minus 7 and x minus 7. Those cancel out. There's nothing more that cancels, so we would have x plus 7 times 1 is just x plus 7 in our numerator, and the denominator would be 10x squared. So that would be our answer. So we'd have 10x squared, or 10x plus 7 divided by 10x squared, with the restriction of x can't equal 0 or 7. All right, let's look at the next one. So for number 8, again, we want to start by looking to see what we can factor. There's nothing I can factor from the first fraction. So that's going to stay 5x over x plus 7. Also, we want to recognize that we're multiplying here. Should have mentioned that. We're multiplying, so that's significant. And then the other fraction, I can factor the numerator. Again, that's one of these where our leading coefficient is 1. So it's going to factor down easily. So we're looking for two numbers that multiply together to be negative 28 that add together to be a positive 3. Well, that would be a positive 7 and negative 4, because 7 times negative 4 is a negative 28, and 7 minus 4 is a positive 3. And our denominator, we can't do anything with that yet. We're going to leave that as x minus 4. Again, before we find what this would simplify to be, I always like to find the restrictions in our domain. I like to do that first. And so I see that we have x minus 4 here. If I set that equal to 0, I would get 4 as my answer. So we can't have x being 4. If I set x plus 7 equal to 0, because remember we do that because you don't want to have 0 in our denominator. So if I set that equal to 0, I would get negative 7 as our answer. So x can't equal 4 and x can't equal negative 7. All right, so now let's see what we can cancel out. The x plus 7's cancel out. And look at this, the x minus 4's also cancel out. So we're left with just 5x. So our answer is 5x with restriction in our domain that x can't equal 4 and x can't equal negative 7. And again, the reason why I like to do the domain first is because when I was a student, I would oftentimes forget after simplifying it, and I would say that, ooh, well, my answer is just 5x, so there is no restrictions. I'd forget that we did have a fraction here earlier, so we got to be careful with that. So I always like to find the restrictions in our domain first before simplifying. All right, notice this one here, we're dividing as opposed to the other ones, we were multiplying. So that means that we don't divide by fractions, we multiply by its reciprocal. So what we're going to do with this one is we're going to, the first piece there, the 6x minus 3, you might think that can't factor, but it does have a greatest common factor of 3. So I'm going to factor a 3 out, leaving me with x minus 1 divided by 10. But I'm going to change this to multiplying, so what we're going to do is we're going to take the reciprocal, so that 5 would be in our numerator. And the 12x minus 6, I see that I can factor a 6 out of that, so I'm going to, when I do that, I would have, whoops, and up here I just realized I forgot something. I forgot my 2x there. 6 divided by 3 would be 2. And then when we divide the second fraction, 12x minus 6, when I factor out a 6 there, we would get 2x minus 1 there as well. So again, let's look at how we restrict the domain for this one. So when we restrict our domain, remember our restrictions only come from where we have a factor with an x. The 10, the 6, we're not going to get a restriction from there because that's not going to have any impact, where the x will have an impact on our answer here. So I want to set 2x minus 1 equal to 0. So when I do that, I would add 1 to both sides to get 2x equals 1. If I divide by 2, I get that x can't equal 1/2. Okay, so there's our only restriction. X can't equal 1/2. But now let's look to see what this simplifies to be. I see that the 2x minus 1's cancel out. And I see that 3, that goes into 6 2 times. I see that 5 goes into 5 1 time, and 5 goes into 10 2 times. There's nothing more to simplify here. So 1 times 1 is 1. 2 times 2 is 4. So we get 1/4. Now, let's say if you didn't recognize that. Let's say if you had just multiplied those. We had a 3 here. If I just multiplied these together, you'd want to recognize that we have a fraction that can be reduced. So if I took 3 times 5 and got 15, and 10 times 6 and get 60, I'd want to reduce that. And you could reduce it a number of times. Maybe you'd start with 5. 5 goes into 15 3 times. 5 goes into 60 12 times. And you'd see that that reduces to 1/4. So either way, you're going to get 1/4 as your answer. Personally, I think it's much easier to reduce first and then multiply those together to get 1/4. But that'd be your answer for that last problem in this orange section.